How do we find the distance between 2 points? Let's talk about it. Hi, I'm Dr. Finch, and I have a PhD in mathematics and over 20 years of experience in education. All right, before we go into our problem where we're finding the distance between the 2 points, 2 comma 5 and negative 4 comma 1, let's review. So, remember the Pythagorean theorem from way back when? We have this beautiful theorem that actually Pythagoras didn't come up with, but it got, the credit like some of that. Sometimes that stuff happens. A squared plus b squared is equal to c squared. I just want to make a mention that a lot of different cultures came up with the Pythagorean theorem because it is quite nice and useful. Okay, so Pythagorean theorem, we have that. We are going to use that to find the distance between 2 points. If we put something on an XY axis and we have 2 points, so we have our first point x1, y1, and our second point x1, 2, y2, we're looking to find the distance, so that would be the length between those 2 points. We can think of that as the hypotenuse of a right triangle. So a right triangle has that 90-degree angle in the corner here that we're looking at. And when we look at it this way, we notice that the distance, if we draw a line down and a line over from our 2 points, we meet in this corner point. The distance there is x2 minus x1. So that is going to be our A. We're going to just replace it with x2 minus x1. That's the difference on the x-axis. And our b is going to be replaced with a y2 minus y1. This is how far we are rising. So we are moving over that far, we are moving up that far, and we just put those letters in for the a, b, and c that we normally see. So we end up with a d squared is equal to x squared minus x2 minus x1 squared plus y2 minus y1 squared. Taking the square root both sides, we end up with our equation that we're going to work with. So here's the one that we have that we are going to use, and that is our d is equal to this equation. A lot of you have seen this before, so hopefully this is just review. If you haven't, it's a really nice equation to have in your back pocket to know for any sort of algebra quiz or exam. Now, if there's a topic that you'd like to cover, that you'd like to see examples on that we haven't talked about, or that you'd like to see more examples on, please email me at purpleffinchmath@gmail.com. I love to hear from you. All right, back up to our problem. We have 2 points and we're trying to find the distance between those 2 points. One of the things that we can do right off the bat is we can take our points and label them x1, y1. And our second point, we will label x2, y2. I like to do the labeling so it helps me keep track of what number goes where when we plug things into our formula. So we have x2 minus x1 squared plus y2 minus y1 squared. All right, so we're going to start off. Notice we are going to take our x2 and we're going to plug that number in. So we have d is equal to the square root of, so instead of x2, we're going to plug in negative 4 minus, and our x1 we see is right over here, so that is the number 2. So negative 4 minus 2, quantity squared, plus, and now we are going to be taking our, let's do this, our y2, which is the value 1, and we are going to subtract from it our y1, which is the value 5. All right, so once we do that, let's start working in our algebra. Negative 4 minus 2 is a negative 6. Keep your parentheses here. Parentheses are your friend. Those negative signs are going to be disappearing because they are inside the parentheses. If they were on the outside, they would tag along. All right, negative 6 squared. Our negatives are going to disappear. 6 squared is 36. Thank you, math facts. And 4 squared is 16. So we have the square root of 36 plus 16, which is the square root of 30, 40, 52. Now, if you have a teacher that lets you stop there, you can. Square root of 52, it's a nice number, perfectly fine. If you have a calculator and you want to plug that in, you can. You're probably going to be asked to round it to some point. If you've watched me for a while, you know that I'm not a fan of calculators. We're going to make this number just a little bit easier to digest so we know roughly what it looks like without a calculator. This is not something you have to do. This is just something that I like to do to practice my math and also because factoring is fun. So I do like factoring. We're going to just break down 52 into its components. We're going to factor that. So we can pull out a 2 and we have 25, 26 left over. Pull out a 2 and we have 13. Depending on how you learn how to factor as a kid, you may or may not be familiar with that method where you just start pulling out copies of whatever you see. We know 52 is even, so we can pull out a 2. We know 26 is even, so we can pull out a 2. 13 is prime, so we just leave it as is. So 52 we can rewrite as 2 times 2 times 13, or 2 squared times 13. I'll keep this in pink. We'll do the rest of this way. So we can rewrite this as the square root of 2 squared times 13. Since we are multiplying, we can break up that square root, and our square root and our squared here cancel out. So another way of writing out our solution would be 2 square root times the square root of 13. So we have a better idea of what that number looks like roughly. Thank you for listening.